Hey folks, welcome to the Neo4j stream. My name's Will, and today we are going to take a hands-on look at the GraphQL Architect low-code tool for building GraphQL APIs with Neo4j. Uh, just have to mute some background noise there. Okay. So if you've been following along with our previous streams as we've been building up the Zillow clone, the real estate search app, we're going to step away from that for a week because I want to dig into this GraphQL Architect tool, which is still pretty new and exciting. And if you're interested in picking up the real estate app, we'll pick that up next week. Cool. So what I want to talk about today is a new tool that's available within Neo4j Desktop called GraphQL Architect. And specifically, this is a graph app. So graph apps, these are tools that you can add and install to Neo4j Desktop that can give you some additional functionality within desktop. So, for example, Neo4j Browser is a graph app. Bloom for visualization is a graph app. You may have seen the GraphQL, the Graph Algorithms Playground, or Neuler for working with graph algorithms. All these are graph apps that add some additional functionality in desktop. And there's a new one that's just been released called GraphQL Architect. And so this is a blog post just kind of walking through the features of GraphQL Architect. So what I want to do is just take a look at some of the features, and then we'll switch over and be pretty hands-on working with GraphQL Architect, building up GraphQL APIs and seeing how it works. So when we say that GraphQL Architect is a low-code tool, we're talking about tools that make it easier for developers to build applications. If I'm a developer, I don't really want to write a whole bunch of boilerplate. Instead, I want to just focus on the things that I have some competitive advantage or some interest in. So what's the functionality of my application? What's the custom logic that I want to add to my GraphQL API? And so GraphQL Architect makes it easy to do that. Yeah, let me zoom in here. Someone in the chat said we can zoom in. Good point. So basically, GraphQL Architect gives us this ability to create a GraphQL API basically with one click of our data in Neo4j. We can add our custom logic with Cipher by editing the GraphQL schema. We have graphical embedded here. If you've ever used graphical with other GraphQL APIs, it's a nice way to query GraphQL APIs. And then we have some ability to export and deploy our GraphQL API because we don't just want it to live within Neo4j Desktop. We want to be able to deploy that somewhere. Cool. So here's this blog post just kind of walks through the ways to install it and walks through some of the functionality, how it works under the scenes. So let's switch over now to Neo4j Desktop and actually see how this works. Cool. So this is a fresh installation of Neo4j Desktop. So in order to use GraphQL Architect, you'll want to have Neo4j Desktop installed. If you don't have it installed, you can download it here, neo4j.com/download. I'll paste that in the chat. And when you go through this process of downloading Neo4j Desktop, what you get is this application, which you can think of Neo4j Desktop as kind of like mission control for working with Neo4j. So I can manage multiple Neo4j projects. We have this default movie database project installed by default. And I can work with multiple Neo4j database instances. I can install plugins, and I can work with graph apps, which we have here, some installed by default. And we don't get Neo4j Architect installed by default. Let me delete that so we can go through the process of installing it. By default, these are the apps that we get. So to install Neo4j GraphQL Architect in Neo4j Desktop, there's a couple ways I can do this. If I'm within Neo4j Desktop directly, I can just click on the Graph Apps gallery. So first click on the Graph Apps slide out and then the Graph Apps gallery. And this shows me a gallery of all of the graph apps that I can install with just one click here. So there's lots of different graph apps. If you haven't seen these before, it's worth taking a look. So for example, the Neo4j ETL tool is useful for importing data into Neo4j from relational databases. Halen is a tool for monitoring the status of our Neo4j cluster, and so on. But today we're interested in GraphQL Architect. So I'll click install, and this will install GraphQL Architect into Neo4j Desktop. Okay, it says, warning, this graph app is going to have access to your data. Do you want to install it? Yes, that's okay, because I want GraphQL Architect to help me build GraphQL APIs, and those APIs are going to have access to my data. That's fine. And so now, to start GraphQL Architect, I can click on this Open dropdown and choose the graph app that I want to open. In this case, I'm interested in GraphQL Architect. So note that GraphQL Architect is launched in the context of a database. So I can have a single database that's activated within Neo4j Desktop at one time. So I can have multiple databases and multiple projects, but only one of those is active at one time. And so when I launch GraphQL Architect, it's done in the context of my active database, which for us is this default movie database that we get initially when we download Neo4j Desktop. Cool, so the first thing that will happen is we'll be asked if we want to execute background Java and Node.js processes. So we say allow, yes, we want to do that. And what's going on there is as soon as GraphQL Architect starts up, it checks if we have existing data in the database. And if we do, it's going to generate a GraphQL API, a GraphQL schema for us. And that's what we see here in the editor. So based on the data that we have in this default movie database, we're running a background process. It's running some Node.js code in the background to generate some GraphQL type definitions based on our data. So let's go ahead and start the GraphQL server here. So we'll click Start GraphQL Server. It says our GraphQL API is ready at localhost port 4000. And if we toggle the editor off, we see that we have graphical available in the background. So graphical allows us to view the schema, so view the documentation for a GraphQL API, or also write queries or mutations, GraphQL operations, and see results. So you'll see this is connected to what's running on localhost port 4000, so that local GraphQL API that GraphQL Architect spun up for us. And right away we can see we have some query entry points for querying data in our API. So we have person or movie. And so let's start off here with movie. and then select the fields we want. So we can look at things like the title, the tagline, the year a movie was released. And what's going on behind the scenes here is GraphQL Architect is running a GraphQL API using a library called Neo4j GraphQL JS. So specifically this library. So this is the underlying library that has the functionality for inferring the schema from Neo4j, for starting the GraphQL API, and for, at query time, taking a GraphQL request, translating that to cipher, sending data to the database, and handling the response. So when we run this GraphQL query, Neo4j GraphQL JS, which is running in the background here, is translating that GraphQL query to cipher, sending it to the database, and showing us some results. Now there's also a lot of additional functionality that's added to our GraphQL API. So you can see just from our type definitions, we're just sort of specifying the fields and the relationships, how the data is connected. And if we take a look in Neo4j browser, which is another graph app. So here, let's do DB schema visualization. And this shows us, okay, so this is the data model in Neo4j. We have nodes with the label person, nodes with the label movie, directed, wrote, produced, reviewed, acted in, and follows relationships. If we select a person node, we can see, okay, they have a name, a date they were born, and so on. So that data model maps to GraphQL accordingly. So for node labels, we create a GraphQL type. So we have type person that maps to nodes in the property graph model with the label person, and similarly for movie. Those properties on the nodes, so for person, person has a name and a date they were born, those become fields in GraphQL. Notice here that every person node has a name, so we know to make that non-nullable by adding the bang here. And for born, well, some person nodes are missing that, so we make that a nullable field by not making that required. And then relationships are indicated as object fields with this relation directive that defines the relationship type and the direction. So these relation directives, these store sort of additional metadata, since in the property graph model, every relationship has a direction and a relationship type. We add that metadata here. Cool, so you can see in our GraphQL type definitions, we're just defining the basic data that's available and how it's connected. And when we run our GraphQL API, it goes through this schema augmentation process where it's adding a query type. We'll look at these later, adding mutations for create, update, delete operations. And we're also adding things like pagination, ordering, and filtering. So some additional functionality. So let's say we want to filter maybe for movies that were released, I don't know, maybe before the year 2000. And also maybe if we add and see how this works here, let's add persons acted in, so all of the actors. And so now what I want to do is now I want to filter for movies that Emil has acted in. So now we can say in our filter argument, we'll add persons acted in sum, where the name of that node is Emil Eifram. And now when we run that, we can see, oh, well, the only movie that Emil has been in is The Matrix. And if you've taken a Neo4j training, you may get the inside joke there that Emil has not acted in The Matrix. In fact, he is the CEO and founder of Neo4j. Cool. So you can learn more about that filtering syntax in the documentation here. So here, for example, we have a very similar schema looking at movies, and we can see how to do more complex filtering. Let me drop that in the chat as well. Filtering documentation. Okay. Cool. So far we've installed GraphQL Architect. We've connected it to an existing Neo4j database, started a GraphQL API without having to write any code, and immediately started querying it. So that's cool. That's useful. Let's take a look at the case where we are using a new blank database. So in this case, we started with this existing movie database, but what about the case where we have, I don't know, my new blank database? So I'm going to create a new blank database in Neo4j Desktop. Go ahead and start that. And once this database is available, then I'll be able to start GraphQL Architect and connect to it. So let's go ahead and do that. And it says GraphQL Architect has dependencies. You're missing the plugin dependencies required, the APOC standard library. So APOC is, or it's also known as Awesome Procedures on Cipher. APOC is the standard library for Neo4j, which includes lots of additional functionality that adds procedures and functions to Cipher. So GraphQL Architect, make sure this is installed because this is used by a couple of specific features in Neo4j GraphQL JS. So we'll go ahead and install that. And slide this window out of the way. We can see what's going to happen here is Neo4j Desktop is going to download the APOC plugin and then restart our database to load that library. Okay, and now when GraphQL Architect starts, it's detected that, well, there's nothing in our database. So we've added a placeholder GraphQL type definition. Yeah, and a question in the chat, if APOC is a standard library, why do you need to install it? Yeah, that's a good question. So APOC is part of Neo4j Labs. So if we go to neo4j.com/labs. So Neo4j Labs is a team within Neo4j. This is the team that I work on that builds extensions and additional functionality integrations with Neo4j. And the goal is to sort of build these things as initial sort of unsupported experiments, and then as they gain traction and prove out to be useful, then to transfer these into proper Neo4j itself. And so APOC is going through that process. So, right, at some point you will not need to install APOC, but not quite there yet. Yeah, good question. Yeah, and feel free if anyone has any questions, feel free to ask in the chat. Okay, so we've started our empty database. GraphQL Architect told us, hey, that database is empty. So here's some simple placeholder GraphQL type definition. So it gives us a single type with the label person that has a string name. Oh, and the other thing I want to mention here, these Neo4j specific scalars. So GraphQL has some basic types that are included, and we can add additional custom scalars. And the Neo4j GraphQL JS library adds custom scalars for the Neo4j native types, things like point, date, time, and so on. So we can use those as types in our GraphQL type definitions as well. That's why they're declared here. Okay, so we can use these GraphQL type definitions in the case of when we're working with a new database. We can use this to drive the data model in Neo4j. So for example, let's start off with something kind of simple. We can start off with a person. We can also, let's give them a person ID. So every person is going to have a name and some unique identifier. Okay, so let's start our GraphQL API. Ready on port 1000. And if we come over here, get rid of that old query. We can see in our generated API that we have a query and mutation type. And in the query type, so these are the entry points for our GraphQL API. Any operation is either a query, mutation, or a subscription, which we won't talk about today, but these are the entry points for our API. So we can either start querying for person nodes. So let's try that. Show me all of the person nodes and their name. And we get back an empty array because there's no data in our database. So that's kind of what we expect. If we look at the mutation type, we can see create person, update person, delete person, and merge person. So this is how we're going to add some data into our database. So let's do a mutation, create person, use a person ID. So I can either assign a person ID of 1, 2, 3, or, and this is specific to the ID fields, I can leave those off when I'm doing the create operation and just give a name. But also let's return the person ID. And what will happen is Neo4j GraphQL JS, when we execute this mutation, if I don't specify an ID field, it will generate a random UUID. Cool, so then I get back, yep, here's my person node with this generated UUID and the name blah, blah, blah. Let's, that's kind of all we can do right now, that we can create person nodes, but they're very lonely. So let's add a little bit to our GraphQL schema here. A question in the chat about touching on best ways to return relationship properties. Yeah, that's a good one. We will definitely touch on that in a second. Let's build up our schema here to be a little bit more complex, and then we can talk about how we can work with relationship properties. Cool, so let's add a little bit more to our schema here. I don't know, maybe company. Company is going to have an ID, and the company, I don't know, is also going to have a name. And then we want to be able to connect the person to the company. So a person is, I don't know, going to work at, person works at a company. And so if you notice, we have some nice schema-aware auto-completion here in our editor. This is powered by the same tools that GraphQL uses under the scenes. So there's a GraphQL language service and a Monaco editor version of the Monaco, a GraphQL version of the Monaco editor as part of the GraphQL project, which is what we've embedded here in GraphQL Architect. There's a bit more in the blog post about that if you want to learn how you can use those tools to build your own sort of applications like GraphQL Architect. But anyway, so we can reference the company. So here's a works at field, which is an object field connected to a company object. We pointed out earlier, we use the relation schema directive to keep track of the direction of the relationship, because in property graph model in Neo4j, every relationship has a direction and a name. So the direction is either going to be in or out. In this case, it's person works at company, so that's going to be going out. And the name, we'll say works at. So person works at company, and then in the case of a company, we can also add a reference here. So a company has many employees, so it's going to be an array of person objects. And we also want to add that relation directive, oops, in this case, the direction is going to be in, right? So person works at company, so the relationship is coming in to the company node, and the name is works at. Cool, so let's restart our GraphQL API. And now if we take a look at the documentation for our mutations, we can see we have a bunch more. So not only do we have create, update, delete person, but we also have create, update, delete, merge company, and then add person works at, add company employees, and those are to create and update the relationships. Cool, so now let's, well, the first thing I want to do, let's query for the person ID for blah, blah, blah. So I'm going to need to use this person ID because if I look at the add company employees mutation, so this is to create a relationship connecting a company and person nodes. It takes a person input. If we look at person input, that is a person ID. So what I want to do now is I want to create a node for a company, and then I want to create a relationship between blah, 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 and this new company that I created. Cool, so that's why I need the person ID. Okay, so now we're going to do another mutation, and we're going to do create company. Let's give it an ID. This will be 1, 2, 3, whatever, and the name is Bob Loblaw's Loblog, and that mutation is going to give us the name and company ID. And then I want to do, at the same time, another operation for add company employees. That's going to create a relationship from Bob Loblaw. So here's the person input for Bob Loblaw. So match on nodes by this person ID. Right, so remember the relationship is person works at company, which is why this is from the person to the company. And then the 2 is company ID for Bob Loblaw's Loblog right here, and the company ID is 1, 2, 3. And then this is going to return a from node, which is the person, and a to node, which is the company. In order to do this in one GraphQL operation, I just need to assign aliases to these operations, I think. So I can just do something like this. Or actually, I guess because they're different operations, I guess this isn't strictly required, maybe? I don't know. We'll do it anyway. Okay, so this now should create a company node and then create a relationship connecting the person to this new company node. Let's run that. And it returns some data. So here's what it returns from my create company. It returns the company node, blah, blah, blah's Loblog. And then for the add company employees operation, it gives me the from and the to node. So from is the person, to is the company. Okay, cool. So that returned some data. We can verify that we actually created that data in Neo4j browser. If you write a query, that is something like match person works at company return star. And we can see, yep, here's Bob Loblaw. He works at Bob Loblaw's Loblog. And sort of the equivalent of that, oops, close GraphQL Architect, the equivalent of that in GraphQL, oops, start our server again, would be person works at company, return person ID and name and company ID and name. All right, so behind the scenes, this GraphQL query gets translated to a cipher query that looks very similar. I guess I closed it. Very similar to that cipher query that we ran. Question, can you use the response from C1 in CE1? Yeah, let's go back to that. So when we ran our mutation, we did this all in one GraphQL operation. So we created the company, and then we created the relationship from the company to the person. And so the question is, okay, well, this create company is going to return a company ID and a name as aliased to C1, And then when I do this operation, can I say, for example, like if I didn't know what the company ID was going to be, remember I said if we don't add an ID field explicitly in the mutation, then we generate this UUID. That's how we ended up with this UUID for the person ID and just the 123 that I put in for the company ID. So the question is, can we use that generated company ID field and then plug it in here instead of like the 123 that we wrote in? So could we do something like this? C1 dot company ID, something like that. And the answer is no, I don't think so. Not like this. So this is sort of sending these operations all together in one request, sending this to the GraphQL API. Instead, what we'd have to do is run these independently. So we'd first have to run this create company, get back the company ID, and then run our add company employees operation and plug in the value here that we got back after we created the company ID, which is why I put in the company ID here so that we could use it so we knew how to refer to the company ID in our add company employees mutation. Yeah, so that's a good question. Test it so we can see the error message. Well, yeah, so if we just do it like this, C1 dot company ID, and we can see that graphical is telling us this is a syntax error. This doesn't make sense as a GraphQL query. This is not sort of the syntax for how we would define variables in GraphQL. Another question, we could use the name instead to connect them. Yeah, so that gets at the question of how do we define these inputs? So let's look at the docs. So our mutation add company employees takes a person input for the from argument and a company input in the to argument. And if we look at these, let's look at the company one, so that's the one we're talking about. So the company input is just a company ID. So if we have an ID field on the, here in our type definitions, on the company type, then that field is used in the input for the create mutation. If we don't have an ID field, so if our company type definition looked like this, then we would treat name as sort of the identifying field for the string, or for sort of the way to represent the company. So if that was the case, we can restart our GraphQL API to see what this looks like. So now, if we go to mutation, add company employees, company inputs, now it is, the company input is a name. Yeah, so good point. So you may see other GraphQL database integrations that use an explicit something like a unique directive or something like that that's indicating, or like I forget which one uses primary key, sort of indicate that like this is the field that defines uniqueness of this type. In Neo4j GraphQL.js, we sort of infer that first by looking for required ID fields, then ID fields, then required string fields, and so on. But yeah, good question. Okay, cool. So, so far we've used GraphQL Architect with two local databases, both an existing database that had some data in it and a new empty database. What if we have a database running in the cloud somewhere, like maybe hosted in Neo4j Aura, or maybe on Neo4j Desktop or on some other service? In that case, how do we use GraphQL Architect in that? How do we do that with Neo4j Desktop? So what I want to do next is spin up a Neo4j Sandbox instance. So we'll log in to Neo4j Sandbox. Let me paste the link here. So Neo4j Sandbox, oh yeah, actually let me step back one step. So Neo4j Sandbox allows us to spin up and run Neo4j instances hosted for us in the cloud somewhere that are still private to us, but come with some data already loaded and sort of a guided experience to walk us through that. So when we sign into Neo4j Sandbox, we are prompted to spin up one of these data sets. We can spin up multiple. So anything from working with crime investigation data to graph data science to World Cup. We just added a contract tracing data set and one specific to fraud detection. What I want to take a look at, though, is the recommendations data set. So we'll launch this. So the recommendations data set, this is kind of a combination of a movie data set, so data from the Open Movies database combined with user ratings from MovieLens. So MovieLens is a commonly used data set for training recommendation systems and machine learning. So this is a useful data set for working with recommendations. Okay, so now this spun up, and I can open this with Neo4j browser. If I wanted to, I could even spin up a GraphQL API on Code Sandbox with just a click if I wanted to do that. But what I want to do is connect this database to GraphQL Architect in Neo4j Desktop. And so to do that, in Neo4j Desktop, what I want to do is add a new remote database. And so it's going to be my recommendations sandbox. So I copied the, oops, that's not the right one. What I want is this bolt URL. So this is the connection string for connecting to our database over the bolt protocol. And then username and password. So I can see here the username is Neo4j and this password is randomly generated for me. And so I do not want to use an encrypted connection. Okay, and we'll click connect. So we said earlier that Neo4j Desktop sort of has one like activated Neo4j instance at a time. And now I want to open GraphQL Architect, which will now be connected to that database that I just created in Neo4j Sandbox. Cool, so again, we can see it is automatically generating type definitions based on the data model. So let's just go ahead and click start GraphQL server. And it says we're ready on port 4000. Let's see if that's true. And we'll search for my favorite movie, which is A River Runs Through It. Let's see if that's in our data set. Let's bring back the title. What else do we have here? Maybe the plot. And let's see the actors. Oops. River runs through it. Spelled that wrong. There we go. And here we're searching just with field arguments that will be an exact match, but I could also do something like filter for where the title contains, I don't know, river. How many river movies are there? Just a few in our data set. Cool. So now we're connected to a remote database. We can use all those same features with GraphQL Architect for running and querying a GraphQL API that we've been using so far. What I want to show now is working with custom logic. So how do I add custom logic to my database? Oh, actually, before we do that, so there was a question earlier, the best way to work with relationship properties. Yeah, and this is a great example because we have some fields with properties on the relationship. So first of all, let's jump into Neo4j browser and take a look at what we mean by relationship properties. So if we look at the data model, db.schema, visualization. So here's the data model. We have actors that have acted in a movie, directors, movies are in a genre, and then we have users that have rated movies. And in the case of the rated, it's a little bigger, in the case of the rated relationships, we are storing some data on this relationship. So in the property graph model, we can store properties on nodes or relationships. If we take a look at this, let's match rated user rated movie. Let's return all of these. Here's the first 10. So here's a user. He's rated a handful of movies. So let's change the caption there. Let's see which movies he's rated. Okay, so here's Omar Huffman. He has just a name and a user ID, and he has rated movies like Time Bandits, Blazing Saddles, The Fly. And if we hover over these rated relationships, we can see the rating that he gave each one of these movies. So in this case, he gave The Fly, or I'm sorry, this is Time Bandits, he gave Time Bandits 1 star at this time. This is a timestamp. We could also use a date time type here. Gave Blazing Saddles a 3 and gave The Fly 2.5. So previously, in the other couple of examples that we were looking at in our GraphQL API, we were just working with node property relationships. So how do we work with properties on relationships? And that was the question from the chat. And the answer is those relationships with properties become their own type in GraphQL. So we add a rated type, and previously we were adding this @relation directive on the individual fields, but here we add it on the type. So we're saying this type rated represents relationships of the type rated, and they connect users to movies. So the from and the to here, these are special fields that we use to indicate the types that this rated relationship type is connected to. And then the other fields on here are what are the properties on that relationship itself. So in this case, we have rating, which is a float, and timestamp, which is an integer. So that's how we represent that in the type definitions. Now at query time, let's see how we can query those. So let's look at one example. So just for a river runs through it, let's look at, oh, and then if we do our autocomplete, let's see, do we have a connection between, so we don't model in this case connection between the movie and the user's rating. We do add it here to the user. So we could query starting from the user, or I think we could add something like this, ratings, rated. But first, let's query from the user, and then we'll come back and go the other way. So user, let's look at first 10 users and their name, and then the rated relationship. And that's going to give us the relationship where we can grab the rating and the timestamp. And then it also gives us the movie. So we can see the title of the movie. So if we run this, for the first 10 users, we'll see their ratings, so what movies they rated, and the rating they assigned. So that's how we can work with relationships with properties. They basically get modeled as relationship types. There's in relationship types in GraphQL. There's a section in the documentation here, specifically relationships with properties. That might be helpful. Drop that in the chat. And I think in the guide here, there's an example in GraphQL schema design, which is helpful as well. It gives us sort of a construct to think about how we map from the property graph to GraphQL. Designing your GraphQL schema. Okay, cool. So, so what I wanted to show next is how do we add custom logic. So let's go back to this query. So working with the river runs thread. So let's say that we're building a, I don't know, movie recommendation application where user is searching for movies, or maybe they put in all the movies that they've watched, and we then want to show them recommended movies that they might be interested in. So to do that, we want to add some custom logic to our GraphQL API. So far, we've just done this using cipher, or using basic CRUD operations with our GraphQL API. What we want to do is now add some custom logic using cipher. So I'm going to update our schema here. Let's add a field called similar. So on the movie type, we'll add a field called similar, and this is going to be an array of movies. And now we're going to use the cipher schema directive. Let's restart our GraphQL API there. And the cipher, statement, there we go. The cipher schema directive takes a single argument, and that is a cipher query. So we have the ability to embed cipher in our GraphQL schema, so sort of to create custom fields that then map to a cipher query that we can define. So in this case, we want to write a cipher query that says, okay, for this movie that we're resolving, find other similar movies that the person who watched this might also be interested in. And there's lots of ways to define that. If you go through the recommendations Neo4j sandbox, you'll see lots of different ways to run recommendation queries in Cipher using graph data science and graph algorithms. This is what I wanted to show, this browser guide that walks through different ways from content-based filtering and collaborative filtering, different ways to generate personalized recommendations. But what I want to do is just come up with a fairly simple cipher statement here. So let's just say we'll look for movies that have the same actors. So that's going to be a fairly simple recommendation. If you like this movie, you'll probably like a movie that has a number of the same actors. So here's the cipher query we're going to add. We're going to say match this. So this in our cipher statement that we're attaching to this field, this then becomes a variable that refers to the movie object that we're currently resolving. So in this case, for this river runs through it node, we want to find the actors that have acted in this movie, and then what other movies have they acted in, and those are going to become my recommendation. So what other movies share the same actors, but we want to come up with some way to score these. So we'll count this number of paths here, so the number of overlapping actors, and then let's return the recommendation ordered by the score in descending order, so the ones with the most number of overlapping actors first. And then we don't want to return all of them. What we want to do is add a field argument on similar. We'll say first, this is going to be an integer, and we'll give it a default value of 3. And any field arguments that we define in our type definitions here on a cipher directive field get passed to the cipher statement as cipher parameters, which we can reference like this. So does that look right? So match this node, find actors that have acted in this movie, find other movies they've acted in, count the number of overlapping actors as the score, group by, do an aggregation here on the recommended movie, return that movie, which matches our return type here, order by the score, and descending, and give us, yes, thanks for pointing that out in the chat. We want first, not limit. Good call, thanks. Yeah, so it matches what we've defined here. So first, not limit. Cool, so let's restart our GraphQL API. And now, close the history tab there. So now we should have a similar field that maps to movies. So let's bring back some recommended movies. So here's some recommended movies. We can see the overlapping actors. So if we now, for each of these similar movies, bring back the actors, and we can see which ones overlap. So this one, so Nightbreed, haven't heard of that, has Craig Sheffer, and I guess just the one. This one also has Craig Sheffer. So I guess we don't have any movies with more than one overlapping actor. But we can change the number of records we want to return. Now let's return 10 similar movies. And so now 10 gets passed into that cipher query. Alien has Tom Skerritt. Yeah, so I guess we don't have any movies that have more than one overlapping actor. Cool, so question in the chat, can I return the score as well along with the similar movie? Yeah, so that's possible. It gets a bit awkward because at this point, so the cipher directive is most useful for adding computed fields that return either a scalar, so if it's like an aggregations, maybe compute, I don't know, like the average score for a movie or something like that, or it's returning a single value, or returning types that map to nodes in the database. We can return types that don't exist in the database. So let's say we wanted to return the score along with the movie node. What we would have to do is create a new type that was something like, I don't know, scored movie, something like that. And it's going to have a score that's going to be an integer, and it's going to have a movie that's going to be a movie, and our similar field is not going to return a movie type, it's going to return a scored movie type. And then in that case, what we have to do is project out the fields that this cipher query is returning into an object that matches this structure. So what we would return is something like this. The score is the score, and the movie is something like this, where we bring out all of the fields in the movie node. The question is, but is that scored movie going to be in the schema now? Object we can't really query the database on. Yeah, right. So so now this scored movie is now going to be added to our GraphQL schema. So if we restart our GraphQL API, and if we take a look in the docs, now we'll see that we have like a scored movie query field. And the scored movie, like this, we don't have any scored movie nodes in the database. So what we want to do is we want to exclude the scored movie type. And to do that, we can add some configuration. So if we take a look in the documents, or in documentation for configuring schema augmentation. And what we want to do here is exclude some certain types. So in the call to make augmented schema, this is happening under the hood in GraphQL Architect, the call to make augmented schema can take a configuration object which identifies some types to exclude from adding to the generated queries and mutations. So that is what we would have to do if we wanted to exclude that from the schema. Let me add that in the chat. Excluding types. Cool. Oh yeah, right. And so that configuration, we don't currently expose in GraphQL Architect. So right now it gets added. That's okay. It's not great in that we don't really want it in there, but it's not going to hurt anything if that's added in the GraphQL API for now as we're developing. It's definitely something that we need to add to expose that configuration. I think we have a GitHub issue for it. By the way, as you're using GraphQL Architect, there is this feedback button that we would really appreciate any feedback that you have, missing functionality, things like that. So missing functionality, we want to expose the schema augmentation configuration. So anytime you come across a missing feature or something like that, please just send in a feedback note. Okay, yeah, so Michael says I'm missing a dot here. Yep, thank you. So what this is going to do, this is going to return a single object for each recommended movie that we have. And it's going to include the score under the score key, and then under the movie key, it's going to grab all the properties of our movie node and add those. So let's see if this works. Any other mistakes in there? Count as score, recommendation return the score, the movie, order by score descending. Yeah, let's try it. So restart our GraphQL API. And for river runs through it. Now similar is no longer of type movie. It's now of type scored movie. So we have a score. That's an integer. And we have a movie. We should be able to get title from. Variable undefined, not defined. So something went wrong in our generated cipher query there. Anyway, to get back to your question of can we do this? We can, assuming we figure out what's wrong with our generated cipher query there. But one thing I want to point out here that is a bit awkward is that we then kind of lose the ability to traverse out from the scored movie node here, because we're sort of statically saying all the fields that are available. Perhaps order by score.score. But score.score doesn't really exist though, does it? I don't think it was specific to, I think it was something in our internal variable undefined is not defined. So if we look at, it's giving us part of the generated cipher query, order by score, descending, limit, first true, movie similar, undefined, and then grabbing the first 10. Yeah, I'm not sure. We'd have to debug and get the full generated cipher query there, which we don't expose currently from GraphQL Architect, but that would be another great feature. Expose the generated cipher query for debug mode. So it would be much more helpful if, as we're using this, we can see the full generated cipher query. So what's going on here is this cipher query is translated, or sorry, this GraphQL query rather is translated into a cipher query, and then within there we're embedding this cipher statement as kind of a subquery. So to properly debug this, we want to be able to see that full query, not just this piece here, to really see what's going on. And from the chat, ran into this, wasn't able to get past it. Thought you might know. Yeah, that's a good point. I've used this before, so I wonder if there's a recent change or something in the version we're using, something is going on. Because we've definitely done this before, and we also, in the GrandStack starter, we do something kind of similar where we compute like an aggregation type. So yeah, something to look into. But yeah, thanks for asking the question. Okay, so there's one last feature that I want to talk about of GraphQL Architect, and that is how do we export this? So we've developed our GraphQL API. It does what we want. We've added our custom logic, and now we want to deploy it somewhere so we can run it on a server connected to our database. So right now, there's two different deployment targets. Oops, slide this down. Two different deployment options. Right now, it just says new project and export to file. So what is going on here? So new project, this will take our GraphQL schema and write somewhere to the file system our schema file that we've created here, along with the boilerplate to be able to run it and connect to a Neo4j instance. So let's make sure we have a directory created for it. Call this my new app. So the reason I'm creating a new directory here is currently we don't create a new directory for the project, so it needs to go into a folder that exists. That's something we will fix soon. So we've selected new project. We go to deploy. Right now we just have this very simple put in the path, users, Lyon WJ, my new app is the directory I just created. If we run that, and it says, yep, we've created this in my new app. Let's make this a bit bigger. So cd my new app. And if I look at what it created a few things. So our schema.graphql file, let's make this a bit bigger. Right, so our schema.graphql file, this is just what we had in our editor. And if we look at index.js, then we can see this is just some boilerplate code for creating a new Apollo server instance, pulling in the Neo4j GraphQL JS library, pulling in the Neo4j driver, pulling in some environment variables from .env file, reading our GraphQL schema, getting our database connection credentials from those environment variables, which we'll talk about where those are in a second. Then we create a GraphQL executable schema object by calling make augmented schema. We create a new Neo4j driver instance, spin up the Apollo server instance. So if we do npm run start, oh, I need to do npm install first. While that's running, oh yeah, my new app, not my new app 2. While that's running, I want to talk about this .env file. So creates this .env file that we can delete this and define these environment variables as secrets however we want, but this is just sort of the default that has the connection credentials. In this case, this is the connection credentials to our Neo4j sandbox instance. Okay, so we did npm install, npm run start. So our GraphQL API is ready on localhost 3000. And if we go to localhost 3000, we have GraphQL Playground. We can see the documentation for our GraphQL API, and we can run GraphQL queries against that. So that's one method of exporting our GraphQL API project. So when we want to create a new project, we want to create the new sort of boilerplate code. The other, which is export to file, that's just going to export a single file, this schema.graphql file. And the case where we use that is when we're using the GrandStack starter project. So here's GrandStack starter project. So the GrandStack starter project has all of the pieces. So not just the bits for our GraphQL API, but also a React front end, with working with Apollo clients, and so on. And if we've created something using the create GrandStack app CLI, so this, then GraphQL Architect works by just replacing the schema.graphql file within the project we've created using the create GrandStack app. So if we do something like npx create GrandStack app, my killer GrandStack app, this is going to pull down the latest version of the GrandStack starter project, install all of the dependencies, go through an interactive CLI to connect to a Neo4j instance. So we could connect to our Neo4j sandbox instance, and then we can pull that GraphQL schema into GraphQL Architect to be able to work with our GraphQL API and then update it in this new project we've created. Anyway, so those are the two sort of initial deployment options, export options that we have now. It's very much a work in progress. I would love to know, are there other deployment targets that folks would be interested in? Something that you could push up to GitHub maybe connect to AWS Lambdas, Netlify, Versal, something like that. So if there's a specific deployment target that you'd be interested in seeing added, please let us know. Cool. So I think that is everything I wanted to cover today. Definitely give GraphQL Architect a try. You can find it in the Graph App gallery. So that's just install.graphapp.io. Graph App gallery. I'll put that in the chat. So from the Graph App gallery, you can access the documentation, the GitHub repo for all of these graph apps, as long as you have Neo4j Desktop installed. Cool, so that's all for today. Thanks everyone for joining, and thanks for all of your questions. And we'll see you next week. Next week, I think we'll pick back up working with our Zillow clone, our real estate search application. So last time we were working with the map and photos. Oh yeah, that's what we did last time. Last time we added photos from the Mapillary API. So I think we'll add some more functionality to our map search. So again, same time next week. We'll see you then. Cheers.